Okay, hello everyone. We're Group 5. Today we're going to talk about Don't Be Fooled by Images Anymore. And this is our group members. 马佑安、王玉婷，还有陈冠希、and 严艺博。Okay. This is our outline. We will take an example about intentional visual manipulation and then uncover cartographers' ingenuity in design. At last, we will provide a few methods about how to avoid it. Okay, first, why we want to talk about this topic? Because in today's society, pictures have become a very popular and effective medium of communication, and they are frequently used to express ideas and emotions in our daily lives, and are a key form of online communication. And however, the increasing misleading pictures has caused negative effects and has hampered people's judgment and decision making. Additionally, our group members have practical experience. During the elections, the internet is saturated with manipulated party maps that falsely depict certain parties receiving more votes despite winning fewer districts. This deliberate editing thus influences people's opinions and choices. Therefore, in a society full of false information, our aim is to investigate image manipulation and provide strategies for avoiding deception.
Okay, now we will show two political examples. First, let's look at the 2016 United States presidential election. The red represents the Republican Party led by Donald Trump, and the red represents the Democratic Party led by Hillary Clinton. And if we only see the map of the vote allocation, we will see that 80% is red and the remaining 20% is blue. So how do you feel after seeing this map? You might think that the red will be the clear winner of this allocation. However, when we see the actual data, we will find that the two candidates were only separated by 77 votes in the allocation. This result is far from what we expected. After these United States examples, we also found a similar situation in Taiwan. Let's look at the 2020 Taiwan presidential election. The blue represents the Kuomintang led by Han Kuo-yu, and the green represents the Democratic Progressive Party led by Tsai Ing-wen. From this map of the vote allocation, it may seem like the blue has a larger proportion. So you might think that the blue has won this allocation. However, when we see the actual data again, we will find that the Green Party won this allocation, and the Green Party won nearly 20% of the vote. Why does this phenomenon occur? My partner will explain it right next.
Okay, now we're discussing why we're misleading by charts. Taking the previous example, there are two reasons why we are deceived. For instance, the distribution in the United States during the 2016 presidential election were not accurately represented by the map. The map showed the distribution of regions instead of voters. So you can see many counties that supported Donald Trump were actually located in large but sparsely populated areas, whereas counties that supported Hillary Clinton were located in densely populated urban areas. Thus, even though it seems like Donald Trump has much more support based on the size of the area, the differences between them was not significant. The same situation occurred during the Taiwan's 2020 presidential election, and the supporters of Han Kuo-yu were in the eastern part of Taiwan and Central Ridge, which covered a large area but have a low population density. On the other hand, the supporters of Tsai Ing-wen were in the western part of Taiwan and 6 municipalities, So in reality, Taiwan has more supporters. Secondly, the use of the wrong type of charts and data classification could also lead to deception. Both charts use complex math. In Chinese, we call 面量图. It placed statistical values directly fill into the area. And however, the data classification used was which political party had the highest vote percentage and what the percentage was. So rather than use directly data, they use relative data. At this point, if the measuring values directly fill into the area, it could be easily interpreted that the larger area also have higher population. This could lead to misunderstanding of population and could give the impression of an advantage based on the size of the area. So if you want to use dot map, which means 点字图, to view the distribution in the United States and Taiwan, it is a more appropriate way because it could show the actual population density. And data classification is more likely to use directly data. And in summary, because map makers intentionally or unintentionally do not convey complete information and use the correct type of chart, viewers, which include us, may subconsciously believe that the one with the larger area is the winner. So this could lead to voting for a wrong candidate. So it is important to be aware of the potential of deception and use the appropriate math and data to make charts.
Okay, here is how we can avoid being deceived by the chart. The first key is critical thinking. It's important to think critically because it's important to think critically. Otherwise, we may carelessly fall into the trap of the chart creator, because for example, we should compare the chart from different perspectives because it isn't easy for us to perceive any errors due to the bias. Also, keeping a skeptical attitude and being more alert are important too. The second key is carefully check the source of the chart. Different historical backgrounds, political systems, and chart creators' standpoints will affect the data. So if we don't check the source of the chart, we may be easily deceived by the chart creator. And so after learning these tips, we can apply them in our daily lives. We can use these tips to better understand where they should be used to maximize their usefulness.
The next part is our conclusion. First, as mentioned above, it's crucial to identify information demonstrated by graphs, charts, or images. If we underestimate the importance of it, we might easily be deceived, which would influence the accuracy of making decisions. And in social psychology, there are two ways people think in daily life. One is automatic thinking, another one is controlled thinking. For example, if we use automatic thinking when we see images, we would instinctively avoid our cognition system it is information overload, so we would use our intuition and our experiences to understand what images tell. So we would jump to conclusion in a very short time. On the other hand, if we use controlled thinking when we see images, we would check more data and search for more information from more reliable sources, and we would reach conclusion after all of these efforts. So if we put critical thinking, which is one of the ways of controlled thinking, into practice, it's very important for us to determine what images really tell. And that's our discussion. The first question is, when you are confronted with the problem of easily be deceived by visual information, how would you do to prevent confusion in the future? And is there anyone who would like to answer this question? Yeah, please.
I think one way to avoid this problem is to be aware of what information the people want to tell us. To know what they stand for, what idea they think they stand for, and what they try to persuasive. So that we would know that some things are not only one way or one perspective.
Yeah, thanks for your answer. And the next question is the same as the next group. So yeah, that's the differences. The degree in these two graphs used makes the conclusion different. And that's the references. Thanks for listening.